Welcome back again. So this is the third part of our fifth lecture. We are working on the toy general equilibrium model. So this is where we left before the break. Okay, so we solved the firm's problem. So the firm found its optimal demand for labor as a function of productivity, X, and real wage. Okay. So of course, with this solution, we have the production, right? In equilibrium, so production is what? It is X times H to the beta. So you have X, beta X divided by real wage to the beta 1 minus beta. Okay? So this becomes your production. Then you also have profit, right? Profit is P times Y. So P times X, beta X, W over P, beta 1 minus beta, minus W times H, and H is beta X, WP, 1 over 1 minus beta. Okay? Now, if you do this math, this profit simplifies into something better looking. All right, I'm going to show you that as well. So now, let me once again remind you the market clearing conditions. Okay, in the labor market, we have HS equals HD. In the good market, we have YS equals CD. So consumption demand must be equal to that. So I can actually denote them by, so here it is just H, and here you can denote it by either Y or C. Okay? So in the equilibrium, these market clearing conditions, of course, should be satisfied. All right? Now, let's count how many endogenous variables we have and exogenous variables we have. Okay? Now, we have H, we have L, we have consumption, we have profit, and we have output, right? We also have prices. Okay? Now let's write these things, and we have, so these are endogenous variables, okay? And we have exogenous variables, which is X, okay? And we also have parameters. Parameters are alpha, beta, and just that, right? Is there any other parameter? No. Right? If you go back to the decision problems, not this one. So if you go back to the decision problems, you see that we have one parameter in the preferences and one parameter in technologies. Okay? So now we want to count the equations, okay? Because at the end, we want to express all of these endogenous variables, okay, as functions of exogenous variable X and the parameters alpha and beta, okay? So let me take a shortcut here and directly show you the results from the handout, so you can better locate them. Okay, this is my mailbox. How can I do that? Okay. That's it. So you see, we have 7 unknowns: consumption, output, labor, leisure, profit, price, and wage. Okay, and these are the equations. So let me zoom in a little bit. Okay, these are the equations, right? So we already defined leisure as a function of profit and wage. We already defined consumption as a function of real wage. Then we have labor, right, defined in this way. We have profit, we have output, we have also kind of a labor market clearing equation, right? And we have output market clearing, good market clearing, right? Now, remember, this is a general equilibrium model, okay? Since this is a general equilibrium model, one of the equations does not provide genuine information about these variables. Why? Because of the Walras law, right? Because if I clear one of the markets, let's say I clear the good market, then this automatically clears the labor market. In other words, the market clearing conditions, 1 minus L equals H and Y equals C, they carry the same information. For this reason, one of them is redundant, okay? So there are actually 6 equations here, not 7, all right? For this reason, I must put a price normalization, as we discussed, remember? So here, that price normalization is P equals 1, okay? Why do we do that? Again, since one of the market clearing equations is redundant, I have to include a new information to the system, okay? So when I normalize price to unity, I put 1 to any place I see the price P, okay? Then I dropped the last equation, okay? The last equation is going to be automatically satisfied because of the Walras law, all right? Then I have 6 equations, 1, 2, 3, 4, 5, 6, and 6 unknowns. What are these unknowns? L, C, H, pi, Y, and W. Okay? That's it. Now, if you do the math, okay, step by step, all right? You're gonna eliminate equations. For instance, you're gonna eliminate Y by noting that income in the economy is equal to the total of profit and wage income. Okay, wage income is WH, profit income is pi. So income, which is equal to output in the meantime, right, with price normalized to 1, then we have this. So you can eliminate Y, and you can drop this equation, the one you see here. Okay. Then then you have 5 equations and 5 unknowns, right? The unknowns are L, C, H, pi, and W. Okay. Now realize from the last equation, L is dependent on H, right here. Then you can eliminate L from the system and drop this equation. Okay. Then you have this. Okay? So you continue this process next by eliminating pi, okay, profit. If you eliminate profit, you're going to have this, right? What did we do? We take profit from here in the third equation and put it in the fourth equation, because that's the only place where profit income appears. So then I have three equations in three unknowns. What are these unknowns? Unknowns are C, H, and W. All right? Now realize one thing. C appears only in the first equation. So if I know wage, if I know W, okay, where's my cursor? Okay. So if I know, all right, just a sec. Okay. So if I know W, I know wage. So I can eliminate C. So if I know W, I know consumption. So I can eliminate C. Okay. All right, something is wrong. Yep. So if I eliminate C, I'm going to have these two equations. Now my unknowns are H and W. Okay. Basically, I eliminate everything from the system and focused on the labor market, right? This is the labor market. Demand and supply. Okay, if you look at it carefully, the first equation is labor demand. The second equation is labor supply. And of course, in equilibrium, demand and supply must be equal. So finally, I can eliminate H from the system. I equate quantity supplied to quantity demanded. Okay, and here I have one equation and one unknown. That unknown is W. Okay, so if you solve this equation, oops, where am I? Okay, if you solve this equation, you're gonna have this. So wage depends on three things. First, it depends on productivity. Okay, so if an economy becomes more productive, in that economy, under competitive conditions, labor suppliers earn a higher wage. Okay, now that proportionality depends on two things: production technology parameter and preference parameter. Okay, production technology parameter and the preference parameter in this particular way. All right, for instance, if the share of consumption good in the utility function alpha, remember, if alpha is higher, marginal utility with respect to consumption is higher, right? Your utility function is alpha ln C plus L. So if alpha is larger, then for given productivity and beta, your wage becomes lower. So you can basically accept a lower wage because you want to consume more. Your marginal utility from consumption is larger relative to those of the leisure. So you can accept a lower wage because of this. Okay. Now, we solved the model. Now, knowing the wage, right? By knowing the wage, you can express, oops, okay, so I'm poorly managing this PDF for now. Okay, so if you know the wage, right, you can now express all the other variables by replacing wage. For instance, consumption becomes alpha beta to the beta times X. So in an economy that is more productive, people can consume more. okay, which is expected because incomes are larger, right, with higher productivity. Now, what happens to labor supply and leisure? Labor supply and leisure are determined by both of technology and preference parameters, alpha and beta, okay? If both alpha and beta is larger, okay, so alpha larger means, again, majority of consumption, which is majority of consumption is larger, and beta larger means the curvature of production technology implies a lower degree of decreasing returns. So it is production functions closer to a linear shape, right? So that increases labor supply. And since labor supply is also determined for the leisure in that sense, leisure is equal to 1 minus alpha beta. So importantly, equilibrium labor supply and leisure decisions do not depend on productivity. Okay, so that's another result. Now, of course, we construct models like this to understand some comparative static analysis, right? What happens to one variable if an exogenous variable changes? What happens to one variable if a parameter changes? Okay, so here you can do this stuff. Here actually you can take simple derivatives to understand these effects. Usually, as we discussed, higher productivity means higher wage and higher consumption, but they do not have any effect. I mean, productivity does not have any effect on these labor supply and leisure decisions. Then here I have a remark. Now, if you use your imagination and if you think about a dynamic version of this economy where productivity is growing, okay? Now, you can put T to every variable, a T index. So you can imagine this particular equilibrium mechanism, this particular exchange will take place in many different periods, not just in one period as we just discussed, all right? If that's true, then what is going on? Look at these equations. If X is growing, right, look at these equations. If X is growing in time, then wages will grow, consumption will grow, all right? But nothing will happen to H and L. Does it make sense? It makes a lot of sense because these variables are between 0 and 1, okay? So I constructed this model and the preference structure using that quasi-logarithmic utility function so that H and L remain as bounded variables. They are bounded between 0 and 1, okay? But it can still be true that productivity is growing, then higher productivity translates into wage, higher productivity translates into incomes and consumption, but not on growing H or growing L, okay? Again, I discuss the changes in alpha here, okay? So how does that shift? So actually you can, again, I'm doing a very poor job, but you can imagine this. Where's that? Yes. So you can imagine, let me now share my white screen again. Oops. Okay. So you can imagine the labor market. Okay. So you have something like that for the supply. Okay, and you can something like that, you have something like that for the demand. Okay. Now if you recall, where is that? So demand, I will just gonna show you. Demand is here. Now P is equal to 1, right? So if X is larger, demand will shift right, okay? Now, look at the supply decision. Supply is here. So, where's supply? Okay, I don't see it here. But supply, as we derive, depends negatively on productivity, given wage, okay? So you have something like this. If X is larger, okay, if productivity is larger, you have a shifting demand, okay? Demand with larger productivity. And this is supply with larger productivity. Okay, so you have no change in that, but higher productivity, of course, will translate into higher wages. Okay. So now you understand the general equilibrium effect, right? Because if this was a model of partial equilibrium, you can take supply as given and increase productivity, but you know increasing productivity also will affect incomes and also will affect labor supply decisions. Okay? So this is the partial equilibrium effect, let's say, all right? This is the partial equilibrium effect. But now this is also shifting, right? So the total effect is the general equilibrium effect. Okay? So this is the beauty of general equilibrium analysis. If something is changing and affecting some part of the economy in a general equilibrium model, that will have some other effect in some other part of the economy. Okay, so that's the richness of a general equilibrium analysis. All right. Now I want to spare enough time for your questions and comments. So let me again share my handout to quickly cover what's remaining. Okay, we discussed these things. Okay, finally, what I want to do is this. Now, as I said before, with a given environment, with a given model environment, you can study many different economic systems. Okay. Now, the system we just studied is a private ownership economy, and free markets operate, right? So this is laissez-faire, right? So there is no government. People take free choices. Okay, they have the freedom of contracting. They have the freedom of ownership. All right, they have the freedom of exercising their economic rights. They have endowments. They can sell these endowments, and then they can purchase stuff in the markets. Markets operate. Nothing and no one is interfering with the operation of free markets. Okay. Now this is sometimes called competitive equilibrium, right? As you know, so this is a competitive Warwazian equilibrium, and sometimes it is called decentralized. Okay, decentralized because there is no central planner, there is no government, there is no a planning organization. Nobody is trying to change the economic equilibrium. Right? Now, there is an alternative, of course, and that alternative is the centralized equilibrium. Now, imagine there is a social planner. Okay, now that social planner could be a central planning office or the president or any other mechanism that will govern the economic system by closing down the markets. Okay, so the economy has the same demographic structure. Again, there will be 1 people, and the same endowments. Again, 1 unit of time, and then same preferences. So that person will still want to enjoy some consumption good and some free time. Okay, and the production technology is the same as well. All right, if productivity is equal to X, and if labor input is equal to H, the production is equal to X times H to the beta. But now, social planner shuts down all markets, okay, and takes the decision for the consumer. So there's no firm. Of course, there is a factory there, but the ownership is public. All right, the central planning office now takes all the decisions and determine directly what the consumer consumes and how much of what amount of time she or he is gonna have leisure. All right, so if you look at the social planner problem, which is expressed here, okay, social planner problem still maximizes the same function, right? The function is the same, but now there are no prices, there's no wage, there is no profit. We only have the resource constraint, right? Because I know my consumption should be less than or equal to my output, okay? And output depends on my labor supply. So what is left of remaining time becomes my leisure. So here, the social planner acts on behalf of the consumer. So it is sometimes called benevolent social planner, or benevolent government, or benevolent dictator. Okay, because here the social planner is itself a dictator, right? He or she is going to dictate that particular solution to this centralized problem. All right. Now, if you solve this problem, guess what? You obtain the same solution. H is the same, C is the same. Okay? H is the same, C is the same. You see the solution of H here and solution of C here. As you see directly, these are the same parametric solutions that we obtain for the competitive or decentralized case. Now, why is that? Why social planner cannot improve the competitive free market equilibrium? Any ideas? Remember the welfare properties and other stuff. We discussed certain reasons when government should interfere or intervene. Here, the centralized solution and decentralized solution are same because there is no reason for the government to interfere. Okay? There is no public good. There is no asymmetric information. There is no externality, and there is no missing market. Okay? 4 general reasons that would legitimize the government intervention or social planner solution, they're absent. Okay? Because there is no public good, because there's no externality, because there is no asymmetric information, because there is no missing market, the centralized solution is identical to the decentralized solution. Okay? Of course, you should ask, in reality, we have public goods, we have externalities, we have asymmetric information. And that's exactly why governments interfere. Governments collect taxes, governments do some redistribution policies, there's fiscal policy there, monetary policy there, regulation policies there, etc. Okay? But in the ideal world, without these frictions, without these sources or causes of market failures, then there's no need for the social planner to intervene, and shut down the market. Okay? That's it. And obviously, of course, this equilibrium is Pareto efficient, right? If you populate this model with more than one consumer with different tastes, with different preferences, then you can imagine that this equilibrium is Pareto efficient according to the first welfare theorem. Okay, we have near 5 minutes, and now I can answer your questions, respond to your comments. We can discuss anything that is unclear. So we have time for that. We can actually log in back again, but now for the discussion, we have around 12.5 minutes. So the floor is yours. Go ahead. Anything? Are you still there, people?
Yeah, we are still here.
Okay. So do you have anything to add or anything to comment on? Any questions?
I have one question. I didn't understand fully why, like in the two markets, but there is one firm and one consumer. I didn't understand why it can be perfectly competitive.
Okay. So the idea is this. Even if there's one firm and one consumer, so one seller and one buyer in both markets, they do not exercise any power to manipulate the prices for their own behalf. Okay, so how can it be? Well, normally, of course, if I am the only buyer and if Yu-Gi-Oh! is the only seller, we have market power, huge market power, right? Now the trick is to imagine this economy is to have an infinite number of consumers, an infinite number of firms, but their mass, their measure is equal to 1. All right, and if they are identical, as I showed before, right? If they are entirely identical, then they behave as a single firm and they behave as a single consumer. But guess what? Since they have now infinite numbers, they do not have any market power left. So they accept prices. Where do we see that in practice? In the decision problem, right? In the decision problem, when we formulate these decision problems, we said these consumers maximize their utility functions by taking prices as given. So consumers become price takers. Similarly, the firm takes a decision on labor demand to maximize profits, and we particularly assumed that the firm will take price and wage as given. So we kind of constructed the model in this way. So we are constructing this model even with one consumer and one firm as if they are price takers. Okay, and the trick is that with unit intervals and with identical consumers and identical firms, there's no difference at the aggregate. Okay, was that clear enough, clarifying enough? I don't know, but
yeah,
you may just imagine we are forcing them to accept the prices in the market. Okay, and that's the idea of competition. So I know I am small enough to not to affect prices. That's the idea. Anything else?
I have no other questions.
All right. All right. So you can always direct your questions to me by email, and you can wait for the next week as well. So in the next week, let me use my last minute to explain what's going to come next. In the next week, we're going to look at chapter 3. There's a model there. It is a significantly larger model with that. I mean, compared to this toy model. So there's N consumer, H consumers, N firms, N goods, and K factors. All right. It will still be, of course, a neoclassical model, and we're gonna and the book is not really diligent on the model environment as I just showed you, but still, I want you to look at the chapter three to have some familiarity with the model, because that would increase your capabilities during the lecture. So I will see you next week then on Wednesday morning again for the sixth lecture. Okay. We are now less than a minute, so I'm ending this meeting if everybody agrees with me. Great. So thank you for showing up again, and see you next week for the sixth lecture. Bye bye.
See you next week,
Görüşürüz
sir.
hocam. İyi günler.
Bye bye.